Okay, today's video is solving systems of linear equations, which you are already familiar with because you learned how to do that with substitution. But today you're going to learn a new method. It's called elimination. Happens to be my favorite method. Real quick, the goal of solving a systems is to create one equation with one variable. And then you're going to repeat this so that you can solve for both of the variables and then write your answer as a coordinate point, xy. The justifications that we're going to use today, there's two of them. It is add by elimination, and I'm going to abbreviate elimination. And we're going to abbreviate that by A, B, E. Now the second abbreviation that we'll use today is when we subtract by elimination. Go ahead and take a guess what the abbreviation is going to be. You're correct. It's SBE. I know somebody's going to make the mistake and think SPE, but they're very different. SBE at subtract by elimination. Couple key ideas before we get into the example. The first is that opposite numbers add to 0. This is a fact. If you add up any opposite numbers, so if you add -5 and 5, which are opposite numbers, you add them up, they're going to equal 0. The same is true for -0.02 plus 0.02. Doesn't matter what the two numbers are, as long as they're opposites, they're going to add to 0. Very similar idea. Same numbers subtract to 0. So if you have the same numbers, let's say you've got 5 and you've got 5, when you subtract them, they're going to equal 0. The same is true for variables. So if you've got 1x and you subtract it from 1x, what you get is 0x. Well, this is a funny thing. It kind of leads us into our other idea, which is the zero product property. And what the zero product property is 0 times anything is 0. So here 0 times x, which is 0, because 0 times anything, no matter it's a number or variable, is 0. 0 times my iPod is 0. And then the last idea today is the zero identity, which is just 0 plus 5 equals 5, or 5 minus 0 equals 5. If you add and subtract 0, it doesn't change the value. Let's go ahead and do a couple examples today. So you can see right away that the equations are very similar to the ones that you use with substitution, but the variables are on the same side. X and Y are together on the top equation, they're together on the left side on the bottom equation. So the system or the process for solving is a little bit different than substitution. It's elimination. Look right now at the coefficients in front of the variables. So we've got -5 and 5, we've got 4 and 3. Now we've got opposite numbers. You can see that the coefficients in front of the x variable are opposite numbers. -5 is the opposite of 5. So because they're opposites, and because we know that when you add opposite numbers to 0, and we want to create an equation with just one variable, we know that our first step here is to add to eliminate. And the opposite numbers is the giveaway. So when we add to eliminate, we just add straight down. So we add x's together, y's together, constants together. So -5 plus 5 is 0. 4 plus 3 is 7. And -14 plus 7 is a -7. Now you can see that we've got an equation with just one variable. And you're thinking, well, there's the x variable right there. Well, remember what we talked about. 0 times anything is 0. And 0 plus anything is whatever you're adding it to. So 0 times x is 0, and 0 plus 7y is just a 7y. So we just took two equations with two variables and created one equation with one variable. It's not x, doesn't have to be, but it's still one variable. Well, how did we do that? We added by elimination. Now our second step here is to solve the resulting equation. So now we're going to solve this resulting equation for y. So we're going to divide by 7, we're going to divide by 7, and we get y equals negative 1. What did we do to both sides? We divided, so we're going to put the justification as dpe. Now, the second step was the easiest step. The third step is to now, well, if we know what y is, we've got to figure out what x is. So we're going to substitute to find the second variable. Well, which equation are we going to use to substitute this negative 1 in for y, the top or the bottom? Well, there's really just a lot of freedom here. I'm going to choose the bottom equation because if you look at the numbers in the equation, they look like they're smaller numbers, and smaller numbers happen to be a little easier to compute. So I'm going to substitute in the negative 1 for y. So 5x plus 3, y is now negative 1. We know that it was being multiplied to the 3, so I'm going to write it like this. How did we do this? We just substituted y. Now we can go ahead and solve for x. So the first thing here is to simplify. We can simplify this multiplication. So we get 5x, 3 times 1 is a negative 3 equals 7. Now we can go ahead and use inverse operations. Let's first start by adding the number that's not connected to the variable. We're left with 5x equals 7 plus 3 is 10. And our final step here is to divide both. Sorry, I added to both sides. I almost forgot. So I get ahead of myself sometimes. And our final step here is to divide. And we get x equals 10 divided by 5 is 2. What did we do? We divided both sides. Now we're going to write our answer as a coordinate point. We know that y is negative 1. We know that x is 2. And we know that coordinate points are written alphabetical order. So 2, negative 1. Here's our second example. Now this is different than the first example, and when you look at these two equations, you'll know why. You're thinking, well, what are we going to do? Add down again? Well, we're actually not going to add down. The reason why we're not going to add down is because if you look at the numbers in front, we've got negative 6 and negative 2. Those are opposites. And we've got a 6 and a 6. Those aren't opposites, but they're the same. So now we've got same numbers. Well, what do we know about same numbers? Let's go back. We know that same numbers, when we subtract them, subtract to 0. And we know that if we get a 0, 0 times that variable is going to be 0, and 0 added to the other variable is just going to be that other variable that we can solve for. So let's go ahead in this example, and for the first step, we're going to subtract to eliminate. So when you subtract to eliminate, you've got to be very careful because you're going to see a lot of double negatives. So if we're subtracting straight down, just like we added straight down, what we have here is negative 6 minus a negative 2. And I'm going to write that out so you can see what that looks like. We've got a negative 6 minus a negative 2. Well, we've got a double negative here. We know that a double negative is a positive, so we've got negative 6 plus 2, that's a negative 4. So we've got negative 4x. We know that 6 minus 6 is 0, so we can just go ahead and write plus, or we should write minus 0, right? I guess it doesn't really matter. We know it's going to be eliminated anyways. Tomato, tomato here. And now 18 minus negative 14. So 18 minus a negative 14. Well, we've got another double negative. They're being added. 18 plus 14, that's 32. How did we go from two equations to just one equation? This time we subtracted by elimination. And now you can see that the variable that's left is the x variable. Last time it was the y, now it's the x. I guess it doesn't really matter which one is left. We know that we're going to solve the resulting equation. So let's go ahead and solve here. Negative 4x equals 32. We're going to go ahead and divide by negative 4. Divide by negative 4. We divided to both sides. We already know what the justification is. Here we're just left with x equals 32 divided by negative 4 is a negative 8. Now, our third step, we're going to substitute to find y. We know x, so we're going to substitute to find y. Which equation should we use? Well, it looks like the bottom equation has smaller numbers, but they've got more negative numbers. 1, 2, top one only has 1. I want to deal with positive numbers. They're just easier for me. So I'm going to go ahead and substitute x, this time, into the top equation. So I've got negative 6 times negative 8 plus 6y equals 18. Now we can go ahead and solve for y. So the first thing we're going to do is simplify. We get a 48. Negative times negative is positive. Plus 6y equals 18. Now we can use inverse operations. So we're going to subtract this 48, subtract this 48, and we subtract it to both sides. These go to 0. We're left with 6y equals 18 minus 48 is a negative 30. Now we can go ahead and divide for our final step. And y equals a negative 5. We can go ahead and write our answer as a coordinate point. Coordinate point here is negative 8 for x and negative 5 for y. Those two previous examples you need to have down in your notes. These two next examples are optional if you feel like you need to go over a couple more. So first step here, look to see opposite numbers, same numbers. So not opposites, not same, not same, but they're opposites. Positive 8 and negative 8 are opposites. So since they're opposites, we're going to add first. So add straight down. And when we do that, what we get is 5 plus negative 4 is a 1x. Those are gone, and we're just left with negative 8. What did we do? We added by elimination. Now we can solve for x. X is already solved for. 1x, we don't need to divide because we know that 1x is just x, so x equals negative 8. We've done step 2. We solved for x. Now step 3 here is to find y. So which equation makes the most sense? I'm going to choose the bottom equation this time because 0 is there and 0 is just an easy number to operate with. So we're going to go ahead and substitute x. When we do that, what we get is negative 4 times negative 8 plus 8y equals 0. We can go ahead and simplify and solve for y now. So let's simplify first. Negative 4 times negative 8 is a positive 32 plus 8y equals 0. Now we can go ahead and subtract the 32. We did it to both sides, so we used SPE. These are 0. We're left with 8y equals a negative 32. Final step here is to divide by 8. Divide by 8. We divide it to both sides, and what we get for y is negative 4. Write it as a coordinate point, and we have negative 8, comma, negative 4. Last example today. So if you're looking here, what's step 1? Are we going to add or subtract? Add or subtract. Opposites or same? Well, those aren't opposites or they're the same. We've got 1 here. We've got a 1 here. Those are the same. So we're going to subtract. Let's go ahead and subtract straight down. We've got 1 minus 1 is 0. Those are gone. We've got 3 minus a negative 5. We've got a double negative. 3 plus 5. That's 8y. And 5 minus 5 is 0. We just subtracted by elimination. And now we can solve for y. So let's go ahead and divide by 8. Divide by 8. And we already know that y equals 0. So we're going to substitute y now. Which equation should we use? I'm going to use the top one because they've got smaller numbers. So we've got x plus 3 times 0 equals 5. Now we can simplify and solve. So let's simplify. We've got x plus 0. We already know that plus 0 doesn't matter. So x equals 5. Write our answer as a coordinate point, and we get 5, 0. So that's 4 examples today. Message me if you still are having some issues, or if you have any concerns, or use one of your classmates. Good luck on the homework.